All right, at the end of every month after filing orders for its regular customers, a coffee company has some pure Colombian coffee and some special blend coffee remaining. The practice of the company has been to package a mixture of those two coffees into 1-pound packages as follows: a low-grade mixture containing 4 ounces of Colombian coffee and 12 ounces of special blend coffee, and a high-grade mixture of 8 ounces of Colombian and 8 ounces of special blend. A profit of $125 per package is made on the low-grade mixture, whereas a profit of $1.75 per package is made on the high-grade mixture. This month, 120 pounds of special blend coffee and 100 pounds of pure Colombian coffee remain. How many packages of each mixture should be prepared to achieve a maximum profit? Assume that all packages prepared can be sold. All right, so we are trying to maximize the profit. So let's let X be the number of packages of low-grade mixture that they're going to sell. And let's let Y be the number of packages of high-grade mixture that they can sell. And notice that we are using ounces and pounds, so we need to remember that 16 ounces makes 1 pound. So in our leftovers, we have 120 pounds of special blend left over. And we have 100 pounds of Colombian left over. So let's convert both of those into ounces. So this would be 1,600 ounces, and then 120 times 16. We get, this is 1,920 ounces. So we're converting our pounds into ounces because in the packages there's ounces. So if we know in our low-grade packages, we have 8 ounces of Colombian, and in our high-grade mixtures, we have, how many? Let's highlight this. So in our low grade, we have 4 ounces of Colombian, and then in our high grade, we have 8 ounces of Colombian. So I know if I take those 4 ounces in my low grade packages plus those 8 ounces in my high grade packages, I need that to be less than or equal to the 1,600 ounces of Colombian that I have total. All right, now let's look at the special blend. In our special blend, in the low grade, we need 12 ounces of special blend. And in the high grade, we need 8 ounces of the special blend. So I know that if I take 12x plus 8y, that needs to be less than or equal to the total number of special blend ounces I have, which is 1920. And then obviously I know that x needs to be greater than or equal to 0, and y needs to be greater than or equal to 0. And we are trying to maximize that amount. So x is greater than or equal to 0, y is greater than or equal to 0, x plus y, 8y is less than or equal to 1,600, 2x plus, or 12x plus 8y is less than or equal to 1920. All right, so let's graph that first one. So 4x plus 8y is less than or equal to 1,600. I'm going to graph that using intercepts. So I would have 400, 0 would be one of the intercepts, and then 0, 200 would be my other intercept. So we're going to go by 100. So 100, 200, 300, 400. That would be my x-intercept. Then 100, 200. That would be my y-intercept. And then we are going to make a straight line. And I know that I want it to be less than that, so I'm going to shade below that. So I'm in this little area right now. And then for my other one, I have 12x plus 8y is less than or equal to 1920. So again, they might not be pretty intercepts, but let's find the intercepts of this. So 1920 divided by 12. Oh, that is pretty. So one of the intercepts, the x-intercept would be 160, 0. And then my y-intercept, 1920 divided by 8 would be 240. So 0, 240. All right, so we're going to change what we went by to make this a little bit easier. So let's go by 20s. So 20, 40, 60, 80, 100. And 20, 40, 60, 80, 100. And then, what were my intercepts? So 400, 0, and 0, 200. So that's one of my intercepts. And then 20, 40, 60, 80, 100. 20, 40, 60, 80, 100. 20, 40, 60, 80, 100. 20, 40, 60, 80, 100. So 400 was the other intercept. And then if I connect those, there we go. And then I wanted to shade below that. And then my other ones intercepts were 160, 0. So 160, so 20, 40, 60. And then at 0 to 40, so here is 240. And then I'll connect those. And then we want it to be less than that. So we're going to shade below there. So my solution set is going to be that little trapezoidy looking shape. And so let's erase the rest that we don't want. So we don't want this blue area in here. So now we need to find the vertices. So my 3 or 4 vertices would be here, 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 and here. So that point is the point 0, 200. And then we have 0, 0. And then we have 160, 0. And then this point where those two intersect look to be at 40 and 180. And again, if we wanted to make sure they intersected at 40, 180, we could solve that system. Or we could graph it. So 4x plus 8y equals 1600. And 12x plus 8y equals 1920. And then if we want to see where those two lines intersect, they intersect at 40, 180, and that's what we had, so we're good. And so we are going to now use those points, our vertices, as test points. So we're going to test 0, 200. We are going to test 0, 0. We're going to test 160, 0. And we're going to test 40, 180. And we're going to plug them into the equation that we wanted to maximize. Oops, we didn't write our maximize equation. So the equation that we are trying to maximize, we make $1.25 for all of the low-grade mixtures, and we make $1.75 for all of the high-grade mixtures. So that's what we are trying to maximize. So we're trying to maximize the profit off of that. So if I plugged in 0, 200, so we have 0.125 times x, so 0, plus 0.175 times y, which was 200. So if I would make a profit of $350 if I made 0 low-grade packages and 200 high-grade packages. If I made 0 of each, I would make a profit of 0. If I did no high-grade mixtures and 160 low-grade mixtures, I would make a profit of $200. And if I did 40 packages of the low-grade and I did 180 packages of the high-grade, I would make a profit of $365. So that's what I want to do. I want to make 40 packages of the low-grade mixture and 180 packages of the high-grade mixture. All right, so your homework is from 11.6.